I think we can get started. So the next session we have is architecting a cloud-native observability data lake for Kubernetes and cloud-native workloads. So we have speakers, Swapnil Kulkarni, who's a founding member at CloudFuse, and Ashish Hanwadikar, CTO and co-founder at CloudFuse. So Swapnil and Ashish are here to talk about leveraging real-time OLAP databases as the foundation of the observability lake, enabling seamless ingestion, storage, and querying of high-volume, time series, and event data. It supports flexible schemas to accommodate evolving telemetry formats and diverse data sources. Over to you, Swapnil and Ashish.
Thank you for kind and warm introduction. So Swapnil and I will be talking about architecting cloud-native observability data lake. As he introduced, I'm Ashish Hanwadikar, and Swapnil Kulkarni is with me to talk about the topic. Swapnil, do you want to start?
So, thank you very much. I think one of the things with observability, right? We'll start with the challenges of observability, wherein as we are moving into more cloud native and Kubernetes workloads, the observability is a challenge in terms of what kind of workloads that we'll get. So pod is the one thing, but beyond pod, we have cloud services, which are cloud, basically S3, EBS, and whatnot, right? You have that. Then you have different workloads, starting from simple application to a monolith or databases or anything, right? Beyond that, you have to have good observability principles. So if you look at traditional observability or monitoring that we are looking at, right? People do not have right set of metrics or right set of instrumentation to send the data, or the logs are not structured, so that are not there, and pipelines and everything. So beyond that, once you have the data, right, the data needs to come in a correct format. So to get that data, you need to have pipelines that will ingest the data, do some transformation on that, and then get to the place where you want. And one of the big thing that we have understood, the 2 points, that when you are storing the data, how you are storing it for the best experience for the user. So how the data lake or the database that is storing the data is structured, and how that can unify the experience for the user. So those are some of the challenges that we have seen in observability when we started with. And I think that is one of the founding principles of building CloudFuse as a platform for observability.
So basically, why observability is so hard for cloud native workloads? One of the distinguishing characteristics is that we have migrated, moved away from monolithic applications, which are very simple to instrument and manage, that are microservices. And those microservices bring a lot of complexity because there are not many of them compared to a single monolithic app. And these microservices communicate with each other a lot more than a traditional monolithic application. You also deploy them much more often. You have CI/CD and continuous deployment pipelines, continuously updating your services in the SaaS environment. That means there is more complexity, more things that can go wrong. You also have a situation where your microservices and databases and all your other services are spread over multiple different cloud, hybrid clouds. Could be using AWS for certain thing, GCP for something, could be using data center to run part of your services. All of this makes it very hard to have observability for cloud native workload. In addition, the cost of downtime for a typical business SaaS application is pretty high. Like a few seconds of downtime per month will end up actually eating into a lot of your revenue and also into your reputation. So what are the basic characteristics? We already talked a little bit about it. Typically cloud native workloads use the orchestrator like Kubernetes and Docker Compose that allows you to scale automatically in response to the workload. You have a lot more scalability because you have to kind of scale your services to meet the demand. You use a lot more complex topology. You also have to handle web as well as mobile clients. So all in all, you basically, together, this presents a very complex scenario for an observability point of view.
As Kubernetes comes into picture, right, for running your application, one of the common challenge that people come up, short-lived resources. So my pods can come and go at any point of time. Because we have auto scaling, they can scale to any level and shrink, right? And to monitor those and to get a visual representation of those, we need to get certain characteristics of that at any point of time. So the matrix is very consistent. Second thing is the data that you are getting because of these number of pods or all the things that are running into your Kubernetes clusters, the cardinality of data is very high. So for a single application, you might have 100 pods running every month, and to see which pod failed why and what is the labels associated that, it becomes a very high cardinality, high data volume. And as the application gets multi-layered, right? When we have multiple stacks into application from front end to back end to middleware and instead of the cloud resources and everything, right? There can be issues at multiple levels. All this needs to be tracked in a single database, and that's a very big challenge. So how I am going to understand, let's say if I have a stack that is running on AWS EKS, running a Java application with a, let's say, Postgres database, how I'm going to correlate all these things together, whether my Postgres was having a high latency or was my application was not responding to the high throughput. Right? So we'll need to understand that that becomes a very big challenge in cloud native workloads. And we have seen that people have systems that kind of gets all these metrics. Okay, and I was talking to someone just outside on the booth. I'm getting all the metrics, but I'm getting false alerts. So alert fatigue is very real. So I'm getting thousands of alerts in a day, and I'm not able to correlate why I'm getting those alerts, or how to resolve those alerts. Right? So that is a very challenge in observability cloud native environments, and we're trying to solve that with a unique approach going forward. So why we are talking about this into a event, right? So the way we want to get to observability is some common practices, right? So we have a number of open source agents that can give you data. So you can use Prometheus for metrics, FileBit for logs. You can use Agar for telemetry. OpenTelemetry has a set of tools that you can for instrumentation. So that is what we are saying, that you use the common tools that everybody can use and send the data in a common format. Beyond that, only sending the data is not enough. The data needs to have common label or consistent labels and tags so that you can correlate that from logs to metrics, metrics to traces, or wherever you are going, right? Then metrics, logs, and traces, we all know. So we are getting that from different sources, but they need to have the same number of tags and everything. And at the same time, they should not be performance intensive. The common thing that there is a matrix overload. So the metrics that I don't need, they are coming to the system, and I'm not able to distinguish between what I need, what I don't need. Same case with logs, same cases with traces, right? So if I'm storing traces for a month, I'm not able to, I'm overloaded and I'm able to get anything out of it. And when we have all these things in place, the important thing is, again, dashboards and alerts. So how can I visualize what I'm getting? Beyond that, how can I alert? So this is what we are trying to put together into a single interface, wherein you start with what you are ingesting, then understand after ingestion how you are going to analyze or store the data, and beyond that, once you analyze and store, how you can help the customer or the user who is using the better dashboards and alerts. So this is one of the pipeline that we can discuss here, doing what we are doing in the CloudFuze itself. So whenever you are getting the data, and I'm talking about metrics here, but it is applicable to any form of data that you are ingesting, right? So whenever you are getting the data, there can be a lot of noise. What people do, they do it with sampling, right? But sampling can reduce the noise, but it can reduce a lot of necessary things as well. For doing that, you can do things like pre-aggregation. So you do not lose the quality of the data, but still you are able to get the meaningful results out of it. Then filter noise, we already talked about, where you can do a sampling and remove unnecessary data. And if your data does not have the necessary tags, so the system should be capable enough to add the data or decorate the metrics or logs or whatever data you are ingesting with right metadata. So for example, I am sending logs from multiple Kubernetes clusters. Okay, one cluster is in, let's say, AP South in India, one is in US East one. And I'm not getting the details of the region itself. So if I'm getting all the data, but I'm not able to that whether my pod in India is failing or the pod in US is failing, the data that I'm getting is of no use to me. Right? So for that, you need to decorate that with right attributes, right? Then few times what is happening is that you are getting a lot of metrics, but the important metrics are not there, because you have to create those on the fly by your own code. Capable to do that. So for example, if you are using OpenTelemetry for tracing, right? You will get a lot of data out of that. But if you want to understand the basics of what is the latency, what is the error rate, and what is the number of requests per second, you need to do some calculation on top of that, and that's where you can generate your own matrix and kind of store that into your own database. And beyond all this, everything in the current deployment model is governed by your infrastructure and how you deploy, right? So if I'm deploying one version today, another version tomorrow, so how I will get what is changing? So you track the deployments, track the infrastructure changes. So earlier I was running a 3-node Kubernetes cluster, now it's a 7-node cluster. Number of metrics will, but you need to understand what changed and why is beneficial or why is not beneficial. So the pipeline basically needs to have some of these steps, not all, or maybe more than this, but this is one of the standard pipeline that we are using for multiple things within our stack, so that the user gets a better experience with the data that they're in.
So basically, after we got the data, we call the agents so that they are collecting all the data, scraping the log, metric, traces, and all that, and they're sending it to the pipeline that Swapnil talked about. Basically, the pipeline did all the transformation, decoration, filtering, generation of metric. All of that happened, then we need to store that data somewhere. And this is where the Observability data lake comes into play. The Observability data lake needs to be able to handle two types of data. One is events data, logs, Kubernetes events, spans, or tracing. And it needs to be able to handle time series data. Time series data basically like for used by the metrics, for example, where there's a value per timestamp, every like 5 minutes, 1 minute, and it also has set of tags. So it could have a metric like CPU usage, and the tags could specify the CPU of which node or which pod or service, and of course the CPU usage value. So you have these two types of data that is need to store to build a data lake that can handle events and time series data in a uniform way. And the tags that Swapnil was talking about that allows you to correlate across all different streams of data, those tags needs to be stored in efficient. Because remember, those tags are going to come with every data point. Every single log line that is going to come to your Observability platform is going to have those set of tags. And sometimes the tags can more than the data. We have seen in the customers where the size of the tag is actually 2 times, 3 times the log line size itself. Same thing with the metric. The metric timestamp and value will fit between like 10 bytes, while the tags will take 100 bytes. So the data lake has to be able to handle efficiently the tags, terms of storage, in terms of query. Imagine being able to say, give me all the logs for a service running in US best one and over like last 24 hours. You have to be able to write indexes, you develop indexes that can actually scan through large amount of data by just when the user is only specifying few of those tags. So the tags have a hierarchical structure. You have top level region, then you have a Kubernetes cluster, namespace. So the tags needs to be able to handle hierarchy of that data, different types of data that include metrics, logs, events, traces, real user monitoring, all sorts of things together and being able to query at scale. And that's why the characteristic of Observability Data Lake is able to handle the tags method. You can handle that properly, then you can build a very nice observability platform on that. And that is one of the main sort of thing that we built at Cloud. Started from the grounds up, some open source components, of course, nobody does start from scratch nowadays. We use Kafka, Apache, and then we built efficient metadata storage. We created something called as value index. And we also built a very efficient storage for storing the values, timestamps, and also some of the data that is not like a tags, but is very high cardinality data like user ID, UIDs for the or IP addresses. They are very high cardinality, but they need to be. So that allows you to, and this is where we are talking about the columnar storage, value storage. Sometimes you need a full text index for searching through. So all of this indexing allows you to do the storage very. Similarly, you have to write a query engine that can handle very large time ranges, different types of stream, metadata, analytics query. Sometimes you don't want to just a set of logs that match tags or you want to be able to count the log lines. You want to be able to extract a facet of the log line. You want to find out how many unique users have visited your website. We are going to extract the user email or ID from the log lines and create a sketch that allows you to count distinct number of users that visited your website versus. So all of that is the query engine. Many of these open source databases, they do have nice interfaces and efficient storage, but the query engine is actually terrible because the data out and operate on it in the Java or Golang. What you want to do, you are running a very large scale complicated queries, you want to be able to send the compute down the storage layer, and that is the push down model. Otherwise, that much data out will kill any data. So that is what we the push down layer, which handles complex queries, joins and filters, and send it to the closer to where the data resides. And ultimately, when people want to query the data, they don't want to learn new language. So they should be able to standard open source query languages like Prometheus, LogQL, any of the standard query languages that people are familiar with, so that they can build a dashboard or use existing public dashboard and input into this. And that is sort of the fourth element of the overall.
So when we have this data lake and unified query layer, right, it kind of helps you with having a unified UI. So what I'm by unified UI is multiple things, right? First thing, when you are operating an observability tool, if I'm having multiple streams for ingestion, let's say logs, metrics, traces, if I have to go from, let's say, one screen to another or one software to another, then you will lose the context. So for example, I'm looking at an error into APM, copy the trace ID I put in logs, search for that. I will need to measure times and where, and then if I can see that from the same place, then a better user experience and a better troubleshooting or a better debugging for the user who is looking at the error, right? So that's what helps with the data lake that we have built. So wherein from the bottom of the stack to the top, so we have everything unified, wherein the tags are same, So the resources can be used for both alerting as well as dashboarding. The resources can be used for doing the correlation from traces to metrics to logs, right? So because they are all either bringing the same set of tags and labels, or if they are not bringing, then based on the additional data that we are getting or generating, we are able to create those tags for them. So basically, the logical models is something that we're talking about from prompt to pod. But then we have infrastructure layer, sending all the infrastructure details. We are basically based on all this application and infrastructure data, we're able to create the visualization. Like the basic is to have dashboards and alerts, but we have something similar like unique like heat maps, wherein you look at a particular time range, then do a correlation across multiple metrics that you're ingesting against, right? So you need to know where it is changing, or which component or which label, look at that. Then we have dependency and geographic maps, wherein we are using a real user monitoring. Then you need to know from where the user is operating my software. What is the geolocation for that? You can do that. And then dependency map, wherein after ingesting the data and distributed tracing, some people like to look at, let's say, the blast radius of my error. So I know my service A is failing, but how many services it is affecting? Is it only B or BCD? Kind of that way. So you can look at that from a service map. And then we have some of the advanced features wherein you can do a drill down using the analytics tools. You can do alerts views, you can have filters, and you can just create the queries out of that and store them, and you can reusably, right? Then some of the things like, let's say, you want to look at certain bigger data frames multiple times, but you don't want to do querying multiple times. So in SQL, we have like views, right? You can create them and you can use it over and over. So similar things we are adding into observability tools as well. So I want to look at large frames of data, but I don't want to do query multiple times, or I don't want to have the load on my data lake to do that. So these are some of the advanced features that we are building on top of the data lake that we already have.
So one thing I want to add is that all of this is connected to the metadata layer I was talking about. If you have uniform set of tags, you can think about guiding those set of tags throughout your observability journey. You could decide, for example, tags to do filtering, to drop the data that doesn't really is. You can use the tags to set policies like how long you want to retain this data. Like you could say that all the data coming from service A should be written for a year. For all the data coming from service B needs to be only written for a month. You can use it for deciding who can access what data. Like you have complex sort of services running for a variety of your customers, and you want to have access control and RBAC. You can say service A and service B should be only viewable by certain set of people, while other services will be viewable by some other people. So the tags allow you to guide you entire through the journey from the ingestion, analytics, access control. You also want to do any kind of shaping, and ultimately in the visualization and alert. In the visualization also, you want to be able to do down and breakdown. There also you want to use consistent set of tags. You want to say, show me the throughput of broken down by service. You want to see the latency broken down by service. Same thing for the alert. You want to get notified by alerting, and that it needs to have tags, like service went down, which service. So if you have uniform set of tags, you can actually, from the ingestion all the way to the alert, you can use those tags and metadata very consistent. The heat maps and dependency map, you can also get a nice breakdown. You can say which are sort of my requests coming to the service are experiencing high latency. There, once you determine that some of the requests coming to the service have high latency, you want to know what are the attributes in your incoming data that can explain that anomalous latency. And so those set of tags will allow you to figure out this is what is causing my service to have high latency. It could be user agent, for example. It could be something like, for example, a service portion of the pods of the service running in a particular availability zone. They could be running on a particular node. So that breakdown also allows you to pinpoint the problem. So if you tag everything consistently, both at the infrastructure level, logical service layer, input characters of the data like user agent, IP addresses, user IDs, you can sort of go through the entire structure in a uniform way. So just to summarize, what we talked so far, observability have grown in the massive, in terms of complexity, they have grown quite a bit, and it is hard to troubleshoot and hard to make sense of what's happening. It is just not about dealing with the problems after they happen. You also want to be able to optimize cost, optimize performance. You want to maintain SLAs. So all of that requires a very complex engineering to deal with the modern application. The tagging, as I was explaining earlier, this is the one that allows you to organize data, observability data coming from ingestion all the way receiving alerts. Modular pipeline, because the data that comes from the agent may not be in the form that you want. You want to be able to transform it, filter it, massage it, shape it the way that you want for your actual observability cases, and that's why you need pipeline. Without pipeline, just taking the data that is thrown at you by the agent and storing it, dumping database is not going to help. You want to have open standard, because without open standard, people are forced to learn what you offer. And it's a lot of training cost, steep learning curve. If you have Prometheus query language, people can learn it, already know it, they can import existing dashboards and all. And because the complexity of the observability is so much, and troubleshooting is hard, you want a very interesting set of complex, not complex, but simplified visualization that allows you to make sense of the observability data. Heat maps, we have something called K-lens. There are a variety of the, like in case of LLM observability today in the keynote, I talked about UMap. All of this allows you to visualize the data in a way that is meaningful to the observability user, like the SRE DevOps team. And that is the sort of final component of the good observability. That's it we have for you. Thanks a lot. Thanks for attending and paying attention.
We have some time, so if there is any questions.
No questions? This is like a pretty quiet class. At least poke some fun and say that this doesn't make sense or whatever.